A very warm welcome from our side here from Dresden, Leibniz-Institut of Ecological, Urban and Regional Development. We are pretty happy and pretty proud to have Joseph Fiksel as our guest scientist, guest lecturer today within our IÖR-Forum. And today we will focus on a science dialogue. We have another format which is on practice dialogue with practitioners. As far as I've seen in the CV with Joseph, it's both. He would be able to give this lecture as a practitioner, but also as a scientist. But today we will focus on this science dialogue. Some few words regarding Joseph's CV. Joseph is a professor emeritus at the Ohio State University. By the way, let me explain or mention at this point that Ohio is also a sister city to the city of Dresden, where we are located. So it's not just having the science dialogue here today, but also kind of Ohio-Dresden sister cities dialogue, which makes us even prouder on that. Yeah, he co-founded the Center for Resilience at the Ohio State University and helped to establish the university-wide Sustainability Institute. So he's really an expert on sustainability and resilience, which we will hear more about today. Joseph holds a BSc from MIT and a PhD in operations research from Stanford University and an advanced degree from La Sorbonne from France. So really international graduation also. Yeah, so I will moderate, I will supervise today. So if you have any points which you want to raise already within the chat, do so. I will follow the chat. On the other hand, I would like to suggest that we follow both presentations. First, the 30 minutes presentation. No, it's more, 45, sorry, 45 minutes presentation from Joseph. And then we have a short, brief presentation from Jessica Hemingway. And then in the end, of course, we will still have enough time for discussions. But even if you want to use the chat beforehand, do so. I will follow the chat. Joseph, the floor is yours. Thanks a lot.
Thank you, Wolfgang. And hello, everybody. Thank you for attending. I'm going to talk about resilience, but first let me start with the subject of sustainability. You're probably aware of the UN Sustainable Development Goals. There's 17 goals, which are very ambitious. What's interesting about this is that all these goals are linked. You really can't achieve any one goal without working on all the others. For example, on the upper left, we talk about clean water and sanitation. That's an essential goal for achieving number 8, which is decent work and economic growth, and number 11, sustainable cities and communities. So I want to talk a little bit about interdependence, because that's part of the challenge of resilience. For example, if you look at water, water is central to what we call the urban metabolism, and Jessica will talk about this a little more later. But we can think of an urban metropolis or even a town as a living system that has a metabolism, and there are flows of nutrients through this, and there are also flows of waste through this metabolism. And we see that water is a central commodity which flows to all of these different needs that humans have. You need water for energy, for mobility, for food, of course, for growth of living things. There are also other things that are essential, materials, land, and so forth. So we've studied these kind of systems, and we've actually tried to develop dynamic simulations of these systems. Later on, I'll show you an example of such a simulation. But the interdependence here is very important and is often neglected because cities tend to operate in different departments. So you have a sanitation department, you have a drinking water department, you have a waste management department. They don't necessarily talk very much. And in terms of planning, their plans tend to be disconnected. For example, the sustainability plan for a city, at least in this country, doesn't necessarily reflect all these important interdependencies. To give you an example, we've studied the Material-Energy-Water Nexus. You may have heard of this. Some people talk about the food-energy-water nexus, but food is only one of many classes of materials that are required for a city to function. And it turns out that these are all interconnected. It takes water and energy to supply food. It takes water to generate energy in most cases. And it takes energy to supply water. And we've actually calculated on the average how much is required of each of these commodities to support the other ones. I won't go into the details. But what happens is if there's an interruption or a shortage of one of these commodities, then we suffer because the others are endangered. For example, there are some sustainability issues here. The large energy footprint of food and materials drives carbon emissions. So that's something we'd like to reduce. But of course, that conflicts with our needs for growth. And then similarly, the large water footprint of food and other materials, the large waste, can't see my slide here. Yeah, the large water footprint of food and other materials endangers freshwater supplies. So these are examples of pressures that exist and threaten the resilience of a community. A lot of the things that cities need to consider is how these commodities interact. We also have potential disruptions or shocks to the system. For example, when you have a loss of energy, a blackout or power failure, that can impair economic growth and quality of life if it lasts a long time. Similarly, events such as floods and droughts threaten communities. So you can see that we have both resilience issues and sustainability issues in this urban metabolism. I'm going to talk specifically about resilience now, because when we talk about sustainability, we're really thinking about the long term, but there are all these disruptive forces that present shocks to the system. And this is really the focus of planning for urban resilience or even enterprise resilience for companies. We need to understand all these disruptive forces. I don't have time to discuss each one, but these are all very real and tend to disrupt the smooth functioning of a city, and in some cases can lead to deterioration of social cohesion, internal conflicts, poverty, and disease. And so we worry about these things as well. We cannot separate these from the longer term sustainability issues. They're all interconnected. So I've argued that sustainability and resilience are complementary. First, let me give you the definition of resilience that we have supported. It's the capacity to survive, adapt, and flourish in a turbulent world. So we recognize the world is highly turbulent. There are shocks and stresses occurring constantly. And these tend to distract us from the longer term vision of sustainability. Sustainability is sort of an idealistic concept that we can live in harmony with the environment and still have our quality of life, economic prosperity, and so forth. And this is possible, but it's becoming increasingly distant today as we see that carbon emissions continue to increase, forest deforestation continues, our oceans are becoming polluted. So we have a lot of sustainability problems. But the more immediate problems are these disruptions that prevent us from focusing on the long-term goals. So I would argue that sustainability makes us more fit for surviving and dealing with these disruptions. So it's a question of fitness for the long term. So I was just saying that sustainability makes us more fit for the journey, if you will. Resilience provides continuity so that we don't suffer major disruptions which prevent us from achieving those long-term goals. To give you an example, in the context of energy, which is a very important topic today, you can differentiate between the sustainability of an energy technology and the resilience of an energy technology. And just for argument's sake, we can say that a small ecological footprint is a measure of sustainability, and that high adaptive capacity is a measure of resilience. And then if you think about different technologies, well, obviously corn ethanol is a non-starter. It's neither resilient nor sustainable, although in the US we subsidized it heavily for many years, but we've recognized now that it really doesn't even make sense from an energy point of view. Return on energy is almost nil. If you look at nuclear energy, well, we talked about that a little bit before we started this. Germany, of course, has taken the step of banning nuclear energy. I believe the nuclear energy, you could argue it has a smaller ecological footprint when it's working fine, but when it's disrupted, it's extremely non-resilient. It's very hard to bounce back and recover. And in the US, of course, we haven't built any nuclear plants for years because people are just afraid. Sort of the fear factor of nuclear disasters. Diesel backup is another interesting one. In many developing countries, you'll see that diesel backup is used regularly for electricity supply. When we travel to India, almost every restaurant has a diesel motor and running in front of it to make sure that they don't lose energy. So that's fine. It makes them more resilient. On the other hand, it's obviously less sustainable. Now, I would argue that smart grid technologies have the potential to offer more sustainability by combining diverse energy sources, including alternative energy, and even being able to decouple from the grid in the event of a power failure. So I think smart grid certainly offers that potential. So while I said that sustainability and resilience are complementary, there are also trade-offs. And this requires some analysis to understand, what are the right conditions to introduce certain technologies if you're considering both long-term and short-term needs. When we think about cities, there are many different problems that cities have addressed, and there are a lot of good solutions that have been put in place. I've just listed some of these ideas here. Cities are working on things like green infrastructure. You'll hear Jessica talk more about urban acupuncture, which is just one method of creating green infrastructure. But that's certainly a way to create more sustainable water systems. There are urban renewal efforts, the ideas of smart growth, using land intelligently, and of course, economic development and so on. So there are many different initiatives. As I said before, they tend to be disconnected. And often the rationale for introducing these initiatives isn't clear. It's like someone had a great idea and they decided to invest in an urban initiative, but where does it fit within this whole portfolio of possible solutions? So I feel that it's important to have an integrated approach where we consider potential solutions in combination and think about all of their impacts, not just focus on a pet project, if you will. So I have advocated the idea of designing for urban sustainability and resilience, which requires a systematic thinking. What are the potential outcomes of introducing new solutions or new technologies? And think about the full range of stakeholders. So that requires collaboration. It requires city governments to interact with both citizen groups and with businesses, and think about the systemic impacts of new technologies or new policies that they want to introduce, and think about how those different policies or approaches might interact. So this is basically systems thinking. We've done a lot of work on developing metrics that allow cities or companies to assess the value of different initiatives. And we've certainly promoted different strategies, such as biomimicry, for example. I will talk later about circularity. I'll give you an example of how circularity can provide both sustainability and resilience on an urban scale. It's very important to think about cross-scale interactions. Rather than just focusing on a local situation, we need to think about the personal scale. That's human behavior. In other words, if we introduce a local zoning policy, how will people respond to that? Will they find ways to circumvent it? And then, of course, you need to think about the implications on a regional, national, even global scale. Certainly, the question of carbon neutrality and emission reduction has global implications. Then, on a national scale, there are some policies that are instituted at a federal level, but the implications go down to the regional and local scale, and vice versa. Adoption of local approaches may cascade up to a higher scale. So this is something that system scientists have emphasized. It's not often done. So it takes some discipline, and it certainly takes resources, but I think academia can help in this regard by developing both the science and the sort of proof of concept examples that demonstrate how these approaches can work. I won't spend time talking about designing for sustainability because this is well known. I'm just listing here some of the different fields people have worked on in terms of trying to design cities to be more sustainable not just from an environmental point of view, but also from a human needs point of view, providing walkability, quality of life, equity, human dignity, and of course, collaboration among stakeholders. But something that's less well understood is designing for resilience. And this is actually the subject of my most recent book, which is called Resilient by Design. These are things that cities don't think about as much, and yet they're becoming really important. Climate adaptation. How do we prepare for a changing climate instead of just responding to problems? Understanding supply chains. What are the critical supply chains that support a city? Businesses worry about this quite a bit, and we have done a lot of work on supply chain resilience for individual companies. But for a city, this problem magnifies because there are so many critical supply chains that are important for an urban center. So having a diversity of businesses is also important. An example in this country is the city of Detroit, which was at one time, the automotive capital of the world, but has gradually deteriorated and lost a lot of businesses and has been in a state of crisis for years. I mean, they went into bankruptcy at a certain point. So certainly diversity is a sort of a fundamental principle in resilience. And if I'm going to digress for a moment. Resilience is comparable to the phenomenon of resilience in living things. So when I talk about urban resilience, I'm really drawing on an analogy from the natural world. If you think about various species, whether it's plants or animals or microbes, they have tremendous resilience because they have adaptive mechanisms, both short-term in terms of, for example, fight or flight mechanisms, and long-term in terms of evolutionary mechanisms. So nature is inherently resilient. And what led me into studying enterprise and urban resilience is thinking about why can't our social systems and our economic systems function like natural systems? Why can't they be more resilient? And how can we achieve that? So some of the things we can do is try to anticipate disruptions, not just react, but try to understand the forces that could lead to these disruptions. And even if we don't understand, there are some things that you can't predict, like there was a volcano in Iceland that created a cloud of ash, which grounded air travel in Europe. That was a black swan event. Some people have used that term. So you can't always anticipate these disruptions, but perhaps you can be better prepared. You can have a greater recoverability, if you will. And diversity is one example of a strategy for being able to recover. So if you have diverse energy systems and you have a central generation power failure, you still have alternative energy technologies, a diversity of technologies such as wind and solar that can at least partially recover. Another important design principle is adaptability and innovation, the capacity to innovate in the face of new threats that have emerged. I didn't mention cybersecurity, but that's one great example further up on this chart. Cybersecurity is probably one of the greatest threats facing businesses and communities today. Recently in the US, we had hackers bring down a major pipeline that provided natural gas and oil to a large part of the Northeast. So the threats that we face are not just natural disasters and not just accidents, but also deliberate threats from certain segments of society or from various enemies. So we have to think about the whole range of different threats. Some are caused by humans, some are caused by nature. We are probably not well prepared for the kind of remote threats that we haven't thought about. Risk managers tend to focus on the familiar, the immediate threats, the ones that are visible, that they've experienced in the past, get control of those. They don't necessarily think about those distant events, and they can't really, there's no way they can anticipate all the things that can go wrong. So resilience is not just about planning for disruptions, it's also about being prepared for surprises and being adaptable enough and creative and innovative enough to recover and forge on. Now, I talked about indicators, so there are ways to measure resilience and sustainability. I've argued that in the past we tended to measure our ecological footprint as a measure of sustainability, and that's not really enough, in my opinion. We need to focus on delivery of value. What are the things that provide value to humans? And so a lot of the things on the left, the reduction in the ecological footprint, provides some value, but there are other issues. Principal among them is resilience, that require a focus on how are human needs being met and what are the disruptions that can reduce human well-being. I'll give you just a few examples of resilience indicators. So you see, these are system attributes on the left. I mentioned diversity, that's one example. Cohesion is another example. And that's why I say that stakeholder collaboration is very important to assure resilience. Adaptive capacity, productivity. In other words, excuse me, how much resource do we require in order to achieve the metrics of well-being that I talked about before? So, for example, energy productivity is an example. Can we reduce the amount of natural resources required to deliver energy, which means that we become more productive while meeting human needs? And then there are things like vulnerability. What are the disruptive forces, both natural and human caused, that can threaten our safety and well-being? Stability is another example of an indicator. And finally, recoverability, which I've talked about before. So I won't spend more time on this for the sake of moving on, but there's been a lot of good work done on measuring resilience, which is kind of an elusive concept if you think about it. It's like trying to measure risk without having the full information about the probabilities and magnitudes. So to some extent, it takes creativity to think about where are the actual metrics. Now, I said I talk about systemic solutions and circularity as an example. And this topic in itself, we could spend hours talking about circularity and all the good examples that have occurred. At Ohio State, we were involved in a lot of this work. But this diagram shows sort of an overview of the systems concept that we have used here. And we've applied this with businesses as well as with communities. So we distinguish between the industry or economic sectors, which have assets. They draw upon resources from the environment. They have production and supply chain processes that deliver value to the market. So that's value creation. And then you have extraction of value, where communities utilize these products and services to generate well-being. Now, these processes generate waste. So the problem here is we have waste and emissions entering the environment and degrading the environment and possibly endangering the resources that are needed to supply our production processes. Circularity occurs when we're able to recover those wastes. And so recovery, recycling of waste is certainly one way to achieve circularity. Another way, which is more direct, is what we call byproduct synergy. You see where it says BPS, that little green arrow. And this is increasingly pursued by businesses, at least in the US and around the world too. What it means is that byproducts don't have to be waste. Byproducts can be useful. They can either be returned into production processes or possibly even sold, for example, to alternative markets. Converting waste materials could be fabric or used parts or whatever, converting them into useful products for some other application. So that's more direct than recovering municipal wastes and trying to reprocess municipal wastes and find ways to reuse them, although that happens too. For example, the byproducts of energy generation in coal plants, people have been very creative in trying to reuse ash and sludge and so forth. Of course, that's hopefully a vanishing technology. I know it's going away in Germany, but that's a good example of it, how people have tried to be creative and avoid just generating piles of waste. So circularity has benefits for both sustainability and resilience. Circularity, on the one hand, reduces the ecological footprint of our production supply chain processes because we are using less virgin resources. So that's a great thing. At the same time, circularity tends to utilize materials that are close by rather than importing them from far away. So if we can find local sources of waste materials, which are substitutes for virgin materials, then we are actually eliminating long supply chains, which tend to be vulnerable to disruptions. And not only that, we are probably creating local jobs as well. So that's an economic stimulus. The circularity has a lot of hidden benefits that we don't talk about, and one of them is increased resilience. Now, I said I would talk about a case study, and I'm going to spend the rest of the time giving an example of how we've applied this kind of systems thinking on a pretty large scale, really on a watershed scale. I spent some time working with the EPA. I was on loan from Ohio State University. It was a very interesting experience. Well, one of the innovations I introduced was a systems approach to regional modeling that could help to develop policies and strategies for our regional offices. EPA has about 10 regional offices around the country. One of them is in New England. And we focused on the Narragansett Bay watershed, which is a beautiful area. Includes Providence, Rhode Island, Newport, Rhode Island, parts of Massachusetts. And they were experiencing concerns about nutrient pollution. You may be aware of the problem of nutrient pollution. Both nitrogen and phosphorus have increased greatly due to various uses such as wastewater treatment, fertilizer use. These materials tend to be washed into the waterways. They can create algal blooms, which really degrade the ecosystems and of course can impact drinking water. And they certainly are adverse for recreational and tourism activities. which are very important in that Narragansett region. Also, these pollutants are difficult to remove. It's very costly to remove them from drinking water, for example. By the way, automobile exhaust also creates nitrogen, NOx, and energy generation as well. So you have all these dispersed sources, very complex pathways, and it's difficult to find ways to interrupt that flow of nutrients into the environment. So we took a systems view. We studied all the different pathways. The focus here is on nitrogen. I'm just going to talk about nitrogen for now. Phosphorus has related but somewhat different issues. But if we look at nitrogen, you can see all the sources on the left. And then the nitrogen cycle that occurs in the environment. There's some very complex chemistry that goes on, but ultimately it can have greenhouse gas effects. It can also have aquatic effects. It gets widely distributed and converted into different forms. Not being a chemist, I can't tell you all about the details of these reactions, but suffice it to say, it's not easy to model. Nevertheless, we went ahead and we worked with a variety of different contributors, and I think this illustrates the importance of collaboration. Of course, EPA represents federal government, but we also worked with the state government agencies, local government agencies, academics in the area, and there are actually a number of academic institutions in the Narragansett region that have been heavily studying the dynamics of the water movement in the bay. And of course, we worked with NGOs and local businesses and concerned citizens as well. We had stakeholder meetings very early in the project to let them know what we were going to do, what we were going to attempt at least, and got a lot of support and a lot of good ideas from those stakeholders. And then we of course engaged with them as the project continued and showed them the results. So that was a very positive aspect of this project. This diagram here shows the different regions that contribute nitrogen loadings into the waterways. You see some of them are in Massachusetts and some are in Rhode Island. And we were able to measure the proportion of loadings by different sources. We were able to project into the future to see how these were going to change over time. So that was a good starting point, just to understand the loadings. In order to do this kind of modeling, we had to divide the region into boxes. So you can see there's these different colored areas are different boxes. And then the approach we used was called triple value simulation. The idea of triple value is that I don't like the term triple bottom line. So I prefer to talk about triple value creation. How do you create value simultaneously for the environment, for economic activities, and for communities? I think that's the challenge. And so this modeling approach looks at the interactions among these different entities. So we looked at how the loadings impacted environmental resources. What are the implications for industrial activities in the area? How does that impact the water supply for communities? What are the adverse impacts in terms of runoff and wastewater, which impact the environment? And we drew upon many different studies to populate this model using scientific relationships. For example, we had our economists looking at the potential impacts of water degradation on fishing or on tourism, and used historical statistical studies to understand those impacts. Now I can show you the details of the model. The model was implemented using system dynamics, using a commercial software tool. It's a very complex model because it embraces all these different phenomena we're talking about. We were luckily able to build upon a model that had been developed for the World Bank a number of years beforehand. and it was made available to us through the Millennium-Institut, which was a partner in this study. What I'm showing you here is just the highlights. These are the indicators, the major indicators that the model was trying to estimate and project into the future. And so you can see waterborne nutrients and pathogens can result in water degradation, algal blooms, and so on, which negatively impact fishing and tourism, which impacts economic development. And in both cases, there are energy, water, and waste flows from both economic activities and from fishing and tourism, which generate additional pollution. And then we also looked at the impacts on storm runoff, both from industry and from residential and activities. And we looked at how the degradation of the water would impact property values. We looked at job growth and population growth, and ultimately how this would impact income, residential incomes and so forth. So there are a lot of different kind of, in a sense, circular flows and influences in this model. We also then, once we understood the kind of baseline of how these regional variables were interacting, we then looked at solutions. So here you see a variety of different solutions that have been considered by EPA and by other partners that we were working with. The idea of smart growth, I'm not sure if that's a term of art in Germany, but in the US, when we talk about smart growth, it implies a whole lot of urban policies and practices that encourage protection of natural resources and green space, avoidance of uncontrolled growth, which can lead to internal conflicts. It can actually disadvantage certain populations. So there's a variety of policies that go into this to ensure that economic development does not create, for example, more poverty and more pollution in certain regions, that it doesn't impact scarce resources or natural systems that are important to quality of life. I've talked about green infrastructure, and that's a whole set of practices around managing water, and rather than having gray infrastructure, which is large concrete pipes and sewers, that we find ways to use natural systems like bioswales and settling ponds and so on to absorb pollution or to slow down the flow of pollution into waterways. And then you can look at emission reductions on the part of energy and manufacturing, treatment systems. CSO stands for Combined Sewer Overflow Tunnels. At least in the US, we frequently have overflow of the sewer system, and we have spills into waterways that can impact drinking water. So these overflow tunnels are designed to channel this overflow away from populated areas. It's not a very appealing approach, and it's quite expensive. There are various waterway engineering practices as well. We also even looked at aquaculture, in other words, taking advantage of the nutrients in the water to maybe grow food sources, hydroponics, for example. So there are many different interventions that you can introduce into the system. And so once we had this model, we were then able to experiment with it. In fact, we built a human interface so that city planners and federal officials and others involved in the decision making, and even citizens, could try out different approaches. We have on the left, we have sort of a panel where people could suggest what kind of interventions they were going to use, what level of effectiveness they would have, and so forth. And then on the right, you can see that we could choose different indicators and look at the change over time. So, for example, on the top there, we're looking at tourism value added. And the red line indicates the projection given current conditions. and projecting into the future. And then the blue line represents the improvement in tourism value added when you introduce certain interventions. So that's how this thing works. Same thing on the bottom. You can see that total nitrogen loading to the waterways was decreased. That's the blue line as a result of the interventions that were chosen. This was an exciting project, first of its kind that I was aware of, where you had a pragmatic approach using system science to model on a regional watershed level, and yet made it understandable to a layperson. And of course, many of the regulators and the planners that we're talking about are not scientists. They're government officials who have different kinds of training, but they're all able to appreciate and understand this approach. So, for example, we would ask questions like, as population grows, how fast are nitrogen loading going to grow? That's kind of the base case. And then, given these different interventions, can we mitigate that increase? To what extent will they be effective? Can we compare the cost of the interventions relative to the benefits in terms of the benefits of improved water quality, such as tourism value added? And what additional benefits might be realized using low impact development? That's another term for smart growth, a combination of smart growth and green infrastructure to have more pervious surfaces that would reduce the loadings to waterways. And so we could do what if scenarios, did a variety of those. To my mind, this was a great example of how you bridge science, policy, and human values. On the left, you have a scientist who basically understands the phenomena partially, but there's still a lot of unknowns. So we can learn from science, but we don't necessarily have all the answers. On the right-hand side, you have the stakeholders, the citizens, the businesses, and so on, who have certain objectives. They have things they really care about, whether it's profitability or whether it's personal quality of life. These are their objectives, and they expect the government to address them. And so, and in the middle, you have the policymakers who are saying, well, what are the goals and what options do we have? And how can we take into account the needs of the community and then draw upon the science and look at it from a holistic perspective? And there's always going to be uncertainty, of course. One of my favorite sayings, this goes back almost 100 years, but from a gentleman named George Box, a statistician, who said, all models are wrong, but some models are useful. We recognize that this system model is a crude approximation of reality, especially when you have such complex phenomena. But at the same time, it gives you some insights, hopefully helps to identify the most productive directions to move in. Even given all those uncertainties, at least we can make some progress in improving both the sustainability and the resilience of that region. Well, that's it. I'll just mention there's two books that I've drawn upon. One is the Design for Environment, which I published about 15 years ago, and the other is Resilient by Design, which was published in 2015. And the first talks more about designing for sustainability. The second, like I said, is more about the newer topic of resilience. We were very fortunate to have the first Center for Resilience in North America and one of the first in the world. And so we introduced a lot of new thinking, and I personally have enjoyed this tremendously. Jessica Hemingway, who's going to speak next, was one of my first students at Ohio State, and I'm very happy to see that she's gone on to a productive career at the Leibniz-Institut. So that's all for now. Thank you.
Great, Joseph. Thank you very much. Yeah. From all sides. And virtual claps from the audience. Super, fantastic.
Thank you.
Yeah, thanks very much. And again, as I stated right in the beginning, please keep all your questions in mind or note them so that we can collect them after the second presentation, which we will have now. So I hope everyone can see the slides now. And Jessica, the floor is yours, please.
Okay. Okay, so again, my name is Jessica Hemingway. I am a researcher here at the Institute, and I'm going to talk about, I have a short presentation today about urban environmental acupuncture, an approach toward expanding green space in dense European cities. So the value of urban green spaces is well known. So green infrastructure is a part of green spaces. This is a strategically planned network of natural and semi-natural areas that deliver a wide range of ecosystem services. Green infrastructure improves environmental conditions, citizen health, and quality of life, which we know, and they also provide cost-effective alternatives to traditional gray infrastructure. So why not just implement green infrastructure? So now that leads to the challenge of green infrastructure adoption. So we see that the availability of large spaces for green space is difficult to find in cities. When we think about competition due to housing, economic growth, and mobility demands. So we have to think of ways how we can expand green infrastructure and the strategically planned network without the use of new large spaces in some cases. On a broader scale, we can rethink urban metabolism. We have, when we look at cities, we often have a linear flow of resources, energy, materials, people, and information, which leads to material depletion, high environmental impacts, climate change because of high CO2 emissions and high waste generation. So we need to rethink the circular flow of the urban metabolism within cities. This is more sustainable. And we need to think about new patterns of development, which leads to the topic today, urban environmental acupuncture. So this may be an approach toward improving the functional health of a city's urban metabolism. I see specifically as reusing land that sometimes would be considered waste or unusable, and also with the provision of ecosystem services, which I'll talk about. So what are the origins of urban environmental acupuncture? This comes from urban acupuncture, which can be defined as an easily understandable metaphor or heuristic derived from traditional Chinese medicine, in which planning actions stimulate the city's nervous system with tiny interventions that can have a catalytic effect on the organism as a whole. I thought that was really a fitting definition considering I studied planning. And I think it's interesting the thoughts and how Marco Casagrande envisions urban acupuncture. He envisions a post-industrialized third-generation city in which citizens are in tune to nature and aware of the destructiveness of modern humanity to itself and to the environment. So this is partially where urban acupuncture starts to go toward this nature and environment area. If we look in the literature, we see that urban acupuncture is implemented in different ways. So what was a surprise to me in the beginning is how much information you can find about urban acupuncture within gray literature. So newspapers, online blogs, and these are mostly planning and physical design interventions, such as playgrounds, housing rehabilitation, plug-in housing, pedestrian and bike networks. If we look in the peer-reviewed research, we see that this includes both physical and social problems, such as climate change mitigation. The work of Chris Ryan is really interesting in Australia, where he looks at both these physical interventions and bringing society along in the process of mitigating adaptation, climate change. Also, among peer-reviewed research, we see that urban stress is addressed, social dissonance, and often the problem of underutilized and abandoned urban spaces is being addressed. So we see that urban acupuncture is really, you can apply it, or it has been applied in a variety of areas or to address a variety of urban problems. So now I'm going to talk about the Saluta 4CE project that I'm currently a part of. So this stands for Integrated Environmental Management of Small Green Spots in Functional Urban Areas. This is an Interreg Central Europe project. We have project partners in Germany, Poland, Italy, Slovakia, and the Czech Republic. And we have pilot projects in 4 of the countries. So the aim of the project is to protect and develop natural resources and provide a potential solution to urban areas where it's not possible to preserve large open spaces. I think this is an important point because what we're not saying is that large open spaces aren't important. We're saying that using small spaces might be part of the solution where it isn't possible. So definitely, it's still important to plan large spaces for green space where possible. So the idea is that with many small interventions, we can improve access to ecosystem services in urban areas. These can be micro spaces that are underutilized and still attainable, like in our courtyards, alleyways, or other abandoned plots. When we think about reusing underutilized and abandoned spaces, this has a circular aspect, which Joseph mentioned. And now I'm going to provide a couple of examples from the project. So on the left is what one of the sites currently looks like in Liptovský Mikuláš in Slovakia. And on the right-hand side is the rendering of what is planned. It might be being implemented as we speak. So there are different features here. So there are edible plants, herbs, the provision of shrubs and trees for shade. And what I particularly find important is that you see this platform, it almost looks like a stage for children so that children can interact and learn here. And there are also on the periphery some benches. So you see the community can also take part. So it's not only physical interventions, but we see it also has a social aspect to it. Here are two other projects in Alessandria, Italy. So on the top picture, you see that's really unappealing. I don't think anyone would really spend any amount of time there, but if you see on the what is planned for this area, they've planned for impervious surface that it can absorb rainwater, areas for people to bike or walk, so get exercise. And with the trees, they also can provide shade during the hot summer months. What I should add is that most of the pilot projects and the project partners decided this themselves, along with cities, decided to use their project, or the main focus was adapting to high temperatures in cities. So in the bottom picture, we see the before picture on the left. This is just like a grassy area. It looks like people might walk through here once in a while. And after the intervention is implemented, there'll be a space for people to sit and socialize or eat lunch. And you see even the garbage can there, that people could spend time there. Maybe it's expected that they spend a little bit more time there. The provision of shade, of course, and different types of plants, which contribute to biodiversity. Now I'm going to talk about expanding green space in dense European cities using UEA. So I'll talk about the pros on the left and the cons. So the pros make UEA appealing. So through many small interventions, we can increase access to ecosystem services. This contributes to resilience when we think of climate change adaptation. As I mentioned, it's also low budget. So the projects tend to be lower budget in comparison to large projects. It's also, the projects can be relatively rapidly implemented. And I think this is important when we think about climate change adaptation. We need to react really quickly, also, especially to the situation of the cities being really hot in the summer months. You can also think about the availability of sites. So often these small sites are available in comparison to the large sites. So, and then again, we're using underutilized and abandoned land. So this combines both a circularity aspect, reusing land that is sitting abandoned, but bringing it back into the system, implementing ecosystem services, what the cities can now benefit from that. And UEA also has physical and both social interventions. So we have the physical interventions that we're implementing, but we all also have included the community and neighborhoods, different actors within the city from the beginning of the planning process, and even to the end, looking to maintain these small green spots. So also there's the intention to affect long-term change, which I think is really important here. We have gotten questions like, their pilot projects, are they intended to be permanent? And they are. And I think it's important to emphasize this with urban acupuncture, that the measures should affect long-term change when we look at previous research or, So now I'm going to talk about the cons. So these aspects can be improved. These could also be future areas of research. So if we look at the literature, we see that there's inconsistent conceptualization of urban acupuncture. Sometimes we see that tactile urbanism is being interchangeably used with urban acupuncture. And I think they need to be they really need to be defined and separate if we want to move further in using urban acupuncture. So as a result of this, we also see inconsistent implementation. Sometimes it's not clear what counts as urban acupuncture. And this slide, in this slide, I'm attempting to address this problem. Often also the long-term impacts are unknown. There aren't a lot of longitudinal studies, but this isn't a problem that's only occurs with urban acupuncture. Another con is that urban acupuncture can be interpreted as esoteric by some. So this idea of transferring from the human body to the city organism is complex. And I can see there's a difference between maybe working with practitioners and researchers and scientists than when you're giving a public presentation or working with the community. I can imagine that presenting this concept of urban acupuncture could get a little bit complex. So if you're interested to find out more about the Salute4CE website, I have the link here, and here you can find all deliverables from the project and different languages as well. We have a handbook and e-learning manual if you want to learn how to implement urban environmental acupuncture. This includes the methodology for selection of UEA sites. So how do you choose which land is appropriate for the sites and which type of ecosystem services or also plants are suitable here. And my main task so far, and also with my other colleagues here at the Institute, was to create a transnational action plan concept. So this outlines how to implement urban environmental acupuncture. So this is the action planning concept. It's used as a guide in the 4 EU countries to implement 16 pilot projects. And I shared the link here if you'd like to look at that later. So again, if you have questions in the discussion, you can feel free to ask me. And I also work on this project with Juliana Matai and Peter Roth. So you can also contact us later if you have more questions. And I also have the references here. If you're interested in that later, I can send them to you upon request.
Super. Thank you very much, Jessica. Applause from my side here and from the audience, virtual audience as well.